We're here at the Computex 2010 with Marilou Jepson, and right now you have reached a place where the screen's actually going to be in products.
Right. It's very exciting. We're in a half a dozen different product launches starting, I think, tomorrow morning, Tuesday, the start of our Computex.
So right here you're showing it on Windows XP, Ubuntu with the Pixel Qi, and over there Windows 7.
Yeah, Windows 7. This has got integrated touch, so you can move things around. You've got multi-touch on this capacitive touch.
So there's a 10-inch capacitive touchscreen on this one. That's pretty cool.
Yeah, that's right. Apple didn't buy all the 10-inch touch.
No?
So this is a nice install of Ubuntu.
Netbook edition?
Yeah, the Netbook edition. It's Ubuntu 10.04. I just installed it yesterday.
Cool. Are there any drivers or something like that you need to have on the to make your screen work?
No, we can just actually plug these screens directly into different systems. It's a 40-pin LVDS interface, and it's pretty standard. The EDID is actually a Pixel Qi PQI, but it just works fine.
All right, and then you have this shortcut where you do the FN F2.
And these laptops, the manufacturer, well, we're out in the bright sun, so you can't see the backlight. But the whole point of this screen is you can turn the backlight off or on. It's reflective when you turn the backlight off, and looks like an e-paper. And then you turn the backlight on. Yeah, right. So you can move, open up something else maybe.
So the whole blogosphere has been waiting for Pixel Qi to have them in products, and so could you say just a little bit of there was some kind of delay that happened, right? And what was that about?
There was a little bit of delay, and I guess what we're doing is new. We use the huge factories of the world to make our products, and it's a bit like we design a car and we try to send the design to the car factory to make the car. That's what we're doing, in a sense, and what we've done in starting one laptop per child, what I did before starting Pixel Qi. But the economic crisis hit, and so our first factory went through some consolidation with other factories, and that slowed things down. There were no technical problems. There was a factory access problem. It's as if you picked Ford for your first factory, and then you said, okay, fine, I'll try Toyota, that'll be safe. Well, then they went through some problems too. So I can't say the factory names that we're using, but that was the issue. So we're bringing them online fast. It's been difficult for the factories through the economic crisis.
Nice. So so there's something about the font, the quality of the font, that's quite important to have good readability. And so Ubuntu, for example, has a special way of doing the fonts.
Yeah, the subpixel rendering that the Ubuntu people did is really quite nice. Stunning fonts. These are very, very small, probably millimeter high, and it just looks stunning. It doesn't look very good on the standard screen, and it looks great on ours. Because they really, here's the thing, is that the human visual system sees with 3 or 4x resolution in black and white compared to color. Luminance, if you will, instead of chrominance. That's the way information is encoded ever since the first TV systems, NTSC, PAL, CCAM, and MPEG, JPEG, all of them do that. Yet we make screens ordinarily the opposite way. We use a red, green, and blue pixels together make a black and white pixel, which is the opposite of how we see and the opposite of how information is encoded. But the software install base is pretty strong. So there was a lot of work here, I think, on hinting and looking at the borders of this is Digitimes here, the borders of where the pixels end up and so forth. So it looks just very crisp, very stunning text, which is very important for reading.
Is Android has good text as well?
Android does have pretty good text.
Yeah.
I really thought this was a nice install on Ubuntu.
So the 10-inch capacitive demonstration is the visibility of when you have a capacitive compared to non-touch.
Yeah, well, this is the wide view stuff that we've got. We've got wide view working now. We haven't put the wide view with the capacitive touch. Actually, I just saw the first one. It's in our offices right now. Yeah. There's a little rainbow artifact that we've fixed on the capacitive touch. This is a much wider viewing angle that is very good for tablets. I know I'm showing it in an Netbook, but we'll be showing it in a tablet tomorrow. in a variety of different places. So
This viewing angle over there.
that's the steep viewing angle.
Nice.
And then, you know, anywhere you want to look.
So, but still the capacity does add some kind of layer on top somehow. So
That's
it does,
true. Yeah, so we glue this down. Just glue it down it, and it does add a layer on top. So,
Nice.
but it
So
works.
could you say just a word about the OLPC, because they have just announced that they're working with Marvel to do the Exo 3,
Yes.
and they hope to have Pixel Chi. What would you say needs to happen for it to be there in the industry?
The $75 tablet that,
Yeah.
that Nicholas and Marvell have shown is fabulous. We support them. We work very closely with OLPC on all of their screens. They have to decide the exact screen size. We believe the price point is absolutely hittable. It's a function of volume. The way our industry works, again, the car analogy is good. You design a car. If you make 10 of them, they cost a lot. If you make millions of them, they don't cost so much. So it's all a function of moving the volume through the fabs and getting access to the fabs to do that. And that's the big trick. That's what people haven't done before in display. And as a result, a lot of display innovation tends to be lovingly handcrafted prototypes from the lab that then go into sort of these small little pilot facilities for production, which takes years, and by the time that gets done, it's probably missed the window of opportunity. The cost of LCD glass is so cheap. We believe the best way to innovate is to use that manufacturing structure and to create really new designs using that manufacturing structure. The same way you can create innovative chips using a CMOS silicon fab, or the same way you can create innovative code using C.
Yeah.
It's not about the compiler or about the silicon process.
Yeah.
It's about what you can do with the logic and the use of
One thing that needs to happen for the tablets to reach a developing world is that they should be unbreakable, right? And Nicolas Negroponte was talking about the plastic
That's
version.
right, yeah.
What needs to happen for that to work?
There's a big movement here to move away from glass to plastic here in Asia. There's 4 countries in the world that really manufacture LCDs: Taiwan, China, Korea, and Japan in high volume. And there's been a movement to plastic base. Right now what's used is very, very thin glass. And the whole systems are set up to handle these robots and so forth, to handle huge sheets of glass around the fab. And so when you move to plastic, you can do it. You have to be careful about scratching the plastic and handling the plastic and so forth, keeping it clean and ilk. But then also plastic melts at a lower temperature than glass. And so you have to be careful on depositing metal layers and oxide layers and amorphous silicon or low-temp poly layers. But a lot of that work has been done, and it's just a matter of time to switch over into the fabs. And so, you know, the question is it next year? Is it the year after? It's coming, and there's flexible plastic, but just unbreakable is easier. Sure, we want to roll it up, but just unbreakable is easier, and that's coming along.
Unscratchable also? Not scratchable.
There's some hard coatings you can put on the plastic to make that. And then there's also the opposite way. What about healing the plastic? So how do you solve a problem with scratchable? Do you... I think there's something noisy going on here. You know, if you can heal it, or can you make it unscratchable, or is it a combination of those?
All right.
I know Nicholas
How
scratched
about the
his iPad.
visibility of a plastic screen compared to glass? Is there anything you know about? Is it going to be just as good, or?
You know, it's pretty good. Eyeglasses switched to plastic a number of years ago. A lot of people swore the glass was better, but the actual transmission efficiency is okay. Now, plastic tends to yellow a little bit, but you can counter that because you know how it yellows, right? And you know what you can... It doesn't yellow a lot if it's thin, but it can get, you know, a little bit cyan. Make it a little tiny bit bluer, and you're fine.
Cool. All right, so thanks a lot, and let's check all the devices that are actually being shown here at Computex.
Oh yeah, great.
Thanks,
We'll show you those tomorrow.
Okay,
Really
thanks.
looking forward.